Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 2980. Check if bitwise R has trailing zeros. You are given an array of positive integer nums. You have to check if it is possible to select two or more elements in the array such that the bitwise R of selected elements has at least one trailing zero in its binary representation. For example, the binary representation of 5, which is 101, does not have any trailing zero, whereas the binary representation of 4, which has two trailing zeros. Return true if it is possible to select two or more elements whose bitwise or has trailing zeros. Return false otherwise, right? So according to the question, we have to select two or more elements from this array, and while doing a OR operation in that elements will give me a trailing zero. Okay, if those element gives a trailing zero, I want to return true, else I want to return false, right? So see here, here I can take this 1, this 3, otherwise this 1, this 4, 5, otherwise this 1, 2 and 4, 5, anything I can pick any elements, two or more than elements, and I want to just do a OR operation in it, and I want to check whether that there is a trailing zero or not, that is the LSB bit is 0 or not, right? So what is the brute force approach? Brute force approach for this problem is take all possible combinations, like for 1 there may be 2, or we can take 3, or we can take 4, or we can take 5. For 1 we can take 2 3, or 3 4, or 4 5, maybe all possible combinations, and do a OR operation for that each and every combination, and check whether there's a trailing zero or not. So this is the brute force approach. So telling about the complexity, it is so huge, up to n factorial, right? So how to optimize it? First of all, we want to know what is the operation of OR operator, right? What is the operation of OR operator? Let us take OR operator. So if 4 or 5 is equal to 4 is 100, 5 is 101. Now doing OR operation, this will becomes what? 1. This will becomes what? 0. This will becomes what? 1. Because if any one of a bit is 1, is a set bit, then the result will be 1. If all the bits is 0, then only the result will be 0, right? So they are asking us to find the trailing 0. The LSB bit is 0, right? So when does this LSB bit will be 0? If I have a value like this and another value like this, whether my LSB bit will become 0? No, right? To become a 0, it must contain a LSB bit of all numbers 0, right? This is my first approach. This is my first intuition. It's my first logic. Now again, if take for example 6 or 4 or 3 or 2, let us take these are the array elements. Whether I want to take three elements, they are asked us to take two or more elements. If I take 3 elements or 4 elements, is there is any use of it? Because why I am asking is because that is 110 is for 6, 100 is for 4, and 011 is for 3. Okay, it is like doing R. When we are doing R operation 111, it will become 7. But still, if we don't take this, the value will be 110, right? True. So observing this, I can take only 2 elements. In the pair, right? So which are the 2 elements I want to take? What are 2 elements I want to take? The 2 elements that have LSB bit as 0. When will my LSB bit is 0? When the numbers are even, I definitely contain a LSB bit as 0, right? So what are the even numbers here? 6, 4, 2. I said to you already, if there are 2 or more element that can give a LSB bit as 0, then I can get absolutely true. So the core logic in this problem is I want to find, listen here, I want to find the number of even numbers. If the number of even numbers is greater than or equal to 2, I can definitely say true because I can take those 2 or more numbers, and when doing OR, my LSB bit stays 0, right? So I can say if there are even numbers greater than or equal to 2, I can say true, right? So how to find this even number? N and 1 result in 0 means it is even number. It is bit manipulation. This bit manipulation technique, right? Bit manipulation technique. And what is the normal math technique? N mod 2 is equal to 0, then absolutely it is even number, right? These two are for even numbers, right? So this is the approach. Let me give you a solution. See here, c is equal to 0 for nums. Num mod 2 is equal to 0, then I have to do c plus c equal to 1. That means I have to count how many even numbers are there in that array. If the even numbers is greater than or equal to 2, I surely say that I can have a pair in which the LSB is a not a set bit, that is it is 0. When the LSB bit is 0, when I am doing all under the OR operation, I will get 0, right? I get 0, right? So I will return c is greater than or equal to 2. If this condition is satisfied, it returns true, else it returns false. Let me submit it. Its time complexity is n. Time complexity, space complexity. Space complexity is, there is no auxiliary space, it is constant. Time complexity is O of n, because we are just traversing the array once, right? So it is O of n. Fine. So this is the approach. Thank you.